Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability Exercise 5.1. Already in the last videos, we have seen the solutions up to question number 7. Now in this video, we are going to see the solution of 8th sum. So we are supposed to find out all points of discontinuity of f, where f is defined by, this is the given function. For this given function, we have to find out points of discontinuity. So what is the given function? F of x equal to modulus of x by x if x is not equal to 0. So given f of x equal to modulus of x by x, this has to be used if x is not equal to 0. And second function is 0 if x is 0. Okay, since we have a modulus function, we have to redefine the function. And what is the condition given if x is not equal to 0? See, when we have a real line, okay, so if x is less than 0 also, it's not equal to 0. Okay, so lower values, smaller values of 0 also not equal to 0. Greater than 0 also, it's not equal to 0. When we redefine the modulus function, we will get two functions. One is negative, other one is positive. So let's redefine this function first. So when we redefine this function, modulus of x, when we redefine minus x by x and 0, the same 0 I am written. Modulus function, see modulus function when we redefine, we will get the two things. One is positive x, other one is minus x. Minus x I have written, then 0 and x by x. Minus x by x is what? Minus 1. X by x is positive 1. And this has to be used. If x is not equal to 0 means we have to use the first function. Not equal to 0 means it can be either less than 0 or greater than 0. For the negative function, we have to use less than 0. If this is given, 0 is if x is exactly 0. And a positive 1, this has to be used if x is greater than 0. So we have to redefine the modulus function. Now for this one, we have to find out the discontinuity. Okay, now using the if condition, no, we have to break the real line. So what value we can see over here? 0. So at 0 we have to break the real line. Now we can have three cases over here. In case 1, if x is less than 0, that means less than 0 means we have infinite real values we have. So we can have a common name like a c. So f of c has to be find out left hand side of the c values, left hand limit, right hand limit, all three things has to be fine. If all three things if it is same, then we can say x is less than 0, function is continuous, otherwise it's a discontinuous. And after that, in case 2, if x is exactly 0, that means f of 0, left hand limit, right hand limit, we have to find out to check the continuity at 0. Okay, if all three values are same, function is continuous at 0, otherwise it's not continuous. And in case 3, if x is greater than 0, so greater than 0 also infinite values we have, so we must take the common name as a c. Now left hand limit, right hand limit, f of c, all things has to be found. If all same, same concept. If all same, we can say that function is continuous, otherwise function is discontinuous. Okay, now let's start with the case 1. Case 1 condition is what? If x is less than 0. So less than 0 means we have infinite real values. Let c be any real value. We need to write the condition. Condition apply. Any real value means it will take minus infinite to positive infinite meaning. Okay, so here we are going to write the condition. At the same time, c should be less than 0. C can be any real value, but condition applies. C should be less than 0. Now, first we will find out f of c. Okay, so f of c value. What is the c here? Less than 0. If it is less than 0, what is the function we need to take? Minus 1. So f of x equal to minus 1, even f of c is minus 1. For the constant function, whatever input we give, Same constant will be the result. So f of c equal to minus 1. Now left hand limit. Limit x is approaching to the c from left hand side f of x. So for this c, left hand side close values of c also less than 0. So suitable function is what? Same first function, replacing f of x with the first function minus 1. When we apply the limit, since it's a constant, the result will be the same, minus 1. Now right hand limit. Limit x is approaching to the c from right hand side. So from this side, limit value is approaching to the c. So right hand side close values, very close values of the c also, it's less than 0. If it is less than 0, yes, first function we have to replace. So first function is what? Minus 1. So since it's a constant, once we apply the limit, same constant will be the result. So right hand limit value also minus 1. Left hand limit also minus 1. Even f of c is minus 1. So here f of c value, left hand limit, right hand limit, all three are coincides. The values are same. So what is the conclusion? F of x is continuous if x is less than 0. Okay, for if it is x is less than 0, function is continuous over here. Okay, next in case 2, if x is 0, whether function is continuous at this point or not, we have to find out. That is case 2. Case 2, what is the condition? If x is equal to 0. First, let's find out f of 0. If x is exactly 0, function is also 0. F of x is 0. So f of 0 is also 0. I mean, function, if input is 0, output also 0 as per the given question. And next one, left hand limit. Limit x is approaching to the 0 from the left hand side f of x. Okay, where we have 0 here, left hand side close values of 0 is what? Less than 0. If it is less than 0, we have to use the first function. So f of x has to be replaced with the first function, that is minus 1. Now since it's a constant, once we apply the limit value will be the minus 1. Now left hand limit is what? Minus 1. Now right hand side limit. Limit x is approaching to 0 from the right hand side f of x. Okay, so now from right side values are approaching to 0. Right side close values of 0 is what? Greater than 0. If it is greater than 0, we need to choose a third function, that is positive 1. So f of x has to be replaced with the positive 1. Since it's a constant, if we apply the limit, same constant will be the result. Now if we notice here, left hand limit, right hand limit, f of 0, none of the values are same. Okay, so here left hand limit is not equal to right hand limit. All three things has to coincide. First, mainly we will check for the left and right hand limit. Then we will check if the left limits are same. Then we will check with this f of 0 value. But anyway, if none of them are same, so what we can say? Function f of x is discontinuous. So f of x is discontinuous at x equal to 0. Okay, so as of now, we found one discontinuous, that is at x equal to 0 function is one point we found at x equal to 0 function is discontinuous. Next in case 3 is what is the condition? If x is greater than 0, whether function is continuous or not, we are going to find out. Case 3, if x is greater than 0. See, for greater than 0, how many real values we have? Infinite real values we have. So we can have a common name. Let c, small c be any real value. Condition applies. At the same time, c should be greater than 0. First, f of c. What is the condition of the c? Greater than 0. If it is greater than 0, okay, if it is greater than 0, Which function we need to choose? Third function, that is positive 1. So f of c is 1. F of x is 1. F of c also 1. Next one, left hand limit. Limit x is approaching to the c from the left hand side, f of x. So from left hand side for the c, see where it lies, greater than 0. So after 0 only the real number we have taken. So here the close values of the c in the left hand side, no, those values also greater than 0 only. If it is greater than 0, f of x has to be replaced with the third function, that is 1. So replacing f of x with the 1. Once we apply the limit, result is also 1. Now right hand side limit. Limit x is approaching to the c from right hand side f of x. And even right side close values of c will be greater than 0. Then third function will be the suitable, that is positive 1. So once we apply the limit, result also positive 1. Now here f of c value, left hand limit, right hand limit, all three results are same. Here f of c value, left hand limit, right hand limit, all same. So f of x is continuous. So continuous if x is greater than 0. Okay, above three cases, what we found, at which point a function discontinuous? Only at x equal to 0. If x is less than 0 also function is continuous. Okay, if x is exactly 0 only, function discontinuous. And if x is greater than 0 also, function is continuous only. So only throughout the real line, only at x equal to 0, the given function is discontinuous. From above cases, the given function, the given f of x discontinuous only at x equal to 0. So that's all the solution of this 8th sum, and the solution of the 9th sum we will continue in the next video. And thanks for watching. Please do subscribe. Thank you.